Good morning, students. Students, this lesson is of class 9th for the subject of physics. Topic: pressure in fluids, which is covered in chapter 4, pressure in fluids and atmospheric pressure, and is given on page number 84 of your physics textbook titled Concise Physics by Selena Publications, and is being submitted to you on 10th May 2021. So children, let us study what is a fluid. A fluid, a substance which can flow, is called a fluid. What does it mean? Any substance which can flow is termed as fluid. Children, we know that liquids can flow as well as gases can also flow. So, both liquids and gases comes in the category of fluids. Children, now if you place a book on a table, you will observe that the book is applying pressure on the table in downward direction. Even if you stand on the sand, you are applying pressure on the sand. So what does we conclude? It can be concluded that solids exert pressure only on the surface on which it is placed. So solids will be exerting pressure only on the surface on which it is placed. But if we talk about fluids, that means liquid as well as gases. So fluids exert pressure on the bottom as well as on the sides of the container in which it is contained. So you can see figure number 2. In figure number 2, there is a liquid placed inside a container and the liquid is exerting pressure in all the directions, not only downwards but also on the sides of the walls of the container. I hope this is clear. Now students, let us learn a new formula for the pressure exerted by a liquid column. So children, the formula is P, where P stands for pressure. H, here H is not depth. Sorry, it is not height of a container. Rather, H stands for depth of the point from the free surface. Rho, the symbol rho refers to density. Rho stands for density and G is acceleration due to gravity. So children, see figure number 3. You can see a free surface. So from this free surface, if you want to find the pressure at point B, so what is the depth of B from free surface? It is equal to H. So the formula of pressure due to liquid column is P is equal to H rho G. And even the atmosphere is also exerting some pressure which will be taken as P naught. So the net pressure at point B is equal to P naught plus H rho G, where P naught stands for atmospheric pressure. So this formula will be used in the numericals also. So children, from this formula, it can be cleared that pressure is directly proportional to depth of the object from the free surface. And secondly, pressure is also directly proportional to density of the liquid. That is, more is the density of the liquid, more pressure it will exert on the object placed at same level. So now students, you may take a break of 5 minutes and answer the given questions on page number 2 of your PDF. So children, in figure number 4, you can see two cases, case 1 and case 2. Now observe this figure. You can see there is a point A and B in the two containers. So children, you have to tell me, you write down in your notebook also, where pressure is more, at point A or at point B, if you are having container of same sizes and having same liquid inside it. And also write the reason in support of your answer. So this is your first question, and then I'm giving you one more question. That is question number 2. In figure number 5, again, you can see two cases, two containers, and there are 2 points marked at same level. Point P, point Q. Both are marked at same level, but the liquid inside the containers are different. One, you are having water, and in other, you are having mercury. Capital Hg stands for mercury. So you are having two different liquids in different containers in question number 2. So now you can pause this interactive session and write down the solutions. And then you can resume your video further to cross-check your answers. See, out of A and B, where is more pressure and why? Write down the answer, children. So I hope you must have got the answers. So let us see. Answer number 1 is point B is at more depth than point A. And as pressure is directly proportional to depth. Pressure is directly proportional to depth. More is the depth from the free surface, more pressure is exerted by the liquid on the surface. Similarly, in question number 2, out of water and mercury, the density of mercury is more and pressure is directly proportional to density of liquid. So what does it mean? Since density of water is 1000 kg per meter cube, which is less than density of mercury, and the value of density of mercury is 13.6 multiplied by 10 raised to power 3 kg per meter cube. Thus, pressure at point Q is more than pressure experienced by point P. Why? Because the density of mercury is more. So, mercury will be applying more pressure at point Q. Now, children, pressure inside a liquid does not depend on, firstly, the shape and size of the container or vessel in which liquid is contained. So children, see figure number 6. In figure number 6, you can see that in figure number 6, see that you are having three different containers and you have to find pressure at same depth. So here what we have to do, we have to see where the pressure is more. Children, the shape of the containers are different, but the depth from the free surface is equal. Free surface, see, the level of free surface was same, liquid level, and the depth from the free surface is same. Moreover, the density of the liquid is also same. Thus, pressure will not depend on the shape of the vessel. So in all the three cases of figure 6, the pressure will remain same. Similarly, the pressure also does not depend on the area of the surface on which it acts. Children, whatever we have learned, I have formulated it in laws of liquid pressure. So kindly read the laws of liquid pressure, and in this we have discussed all the things which we have read by now. And similarly, after taking 5 to 10 minutes break, you can learn the summary which we have discussed. And here, all these summary part, I have written the formulas which we have already done in first two lectures. And children, these formulas will be used for doing the numerical part of the exercise. Now, if you just open your book on page number 93, you can see numericals of exercise 4A. Children, in these numericals, we will be using the formula pressure is equal to force upon area and thrust, which is equal to weight of a body. In first question, there are two nails, nail A and nail B, whose area is given to you. Children, area was given in millimeter square. So as we have already learned the conversions in our lower classes, millimeter square needs to be converted into meter square. So millimeter square means 10 raised to power minus 6 meter square. And then force was given to you that we are applying a force of 1.5 Newton. Use the formula force upon area, and then you can find pressure applied by the two nails. Similarly, question number 2, mass of iron block is given. So what will be thrust? The formula of thrust is weight of the block. The formula of weight as done in class 8th is m into g, mass into acceleration due to gravity. Since they are telling in the question that you can take g as 10, so 7.5 multiplied by 10 comes out to be 75 newtons. And then we have to find pressure. So the formula of pressure is thrust upon area. So children, thrust we have already calculated, and area of the base of the iron block will be 12 into 8, that is 96 into 10 raised to power minus 4 meters square. Now children, we have done that iron block. See, iron block is solid. Only the base part will apply pressure. Thus, we are taking the area of only base. And question number 3, here we are provided with height of a column, density of water, and G. We have to find pressure and thrust. Children, first of all, let's find pressure. That is H rho G. Put the formula, find the value of H. Put the formula H rho G. Put the values of H, rho and G also. And then your answer of pressure will come in Newton per meter square, which is also known as pascals. And for finding thrust, the formula used will be pressure multiplied by area. So pressure you have found, area is given in centimeter square. So children, convert the centimeter square into meter square. So when centimeter square is converting into meter square, it is 10 raised to power minus 4. And in case of millimeter square into meter square, it is 10 raised to power minus 6. So further, now children, question number 5 and 6 is given in your PDF. So kindly try these two questions yourself. Solution of the two questions is given on page number 6 of the PDF. So kindly try it, and I hope you understand it. It's simple calculation. You just have to substitute the values and then find the answers. Thank you, students.